All right, this week's presentation is on stored procedures. We'll go over what they are, kind of what goes in, what comes out of them, how to call them. There's a couple different ways of executing stored procedures, what you can do kind of inside of them. A little overview on that and how they compare to Scalar and single statement, and which are also called inline statement and multi-statement table value functions. So what is a stored procedure? Most people know about them. They're just kind of an encapsulated set of one or many SQL statements you can run, and you can run it over and over again or call it from multiple places. The execution plan on them is cached along with the parameters that are initially sent to it. Inside of them, you can do updates, inserts, or deletes. You can execute common runtime language procedures, and you can have cursors and loops if you really want to. Input parameters, you can have.
What's CRL?
CRL or CL, yeah, CRLs, common runtime language. So you can create like .NET.
Oh, those are the ones you embed in the.
Yeah,
server.
you create them and you can run them as binary or hex into SQL Server.
Yeah.
You can create a web services listener in there and send web services straight to the SQL Server and have it consume it. Yep, they're pretty cool. So input parameters, you can have hard-coded values. You can have values in variables and run a stored procedure with those variables. You can also have custom data type table variables, which we'll go over in the demo. And that way you can actually pass a temporary table of data into a stored procedure. Once you do that, it is read-only inside of it, though. And on the output side, you can have a single value selected out of a stored procedure. You can have one or many result sets out of a stored procedure. When you have many result sets and you say set no count off, it will return, I can't remember the exact kind of behind the scenes parameter. It's in the demo code, but that gets passed back with every result set. So depending on your application, you can reference result set 1 or result set 2 or result set 3 from one database call. So it can be handy if your application is built for it, but that kind of lends itself to a very complicated application, and that might not be the best kind of clean coding standards. So you can have, so you commonly use set no count on, and that won't return that kind of, this query is done, use this result set until the very last result set. And then your application will usually pick up that last result set. It will ignore the other ones.
Does it depend on the database driver, like?
Question was, depends on the database driver lag?
No,
just the database driver?
Multiple result sets in any language that you would access the database?
I think it's language specific.
Yeah, it would depend on the language.
Language specific and then application specific. In the past, I've worked on applications where it did, naturally handle multiple result set, but you had to kind of code for that and exclude it, or don't forget to have set no count on in the sprocs.
Multiple data sets and one return.
Yeah. All right. So when using output variables, the output variable is declared at the top of a stored procedure as an output variable, and then in your code that is calling the stored procedure, you need to have a variable declared out of there. Declare this output variable, execute your stored procedure using this variable, which is an output, and then you can select that output variable after the store procedure. Methods for calling store procedures. Most commonly, people use, exec store procedure and then the parameters or hard-coded values in a string. That can lend itself to SQL injection sometimes, depending on if they're concatenating statements together to generate the parameters. And then there's also execute execute SQL, and that is a fully parameterized way to execute any SQL statement, store procedure or not. It will also not cache the parameters. So when you run the first time you run a store procedure, it will cache the parameters in the call. And when you use the SP execute, there's less chance of that happening. I'll have examples for these in the demo. So what can you do in store procedures? You can do inserts, updates, or deletes. You can use any deterministic functions, ones that the SQL server knows will return the same data every time you ask them or you run them, and non-deterministic functions. So any user-defined functions or server functions like getDate, which is always changing every time you run it. You can run CLRs. And you can execute dynamic SQL inside of them, build up a SQL statement and then hopefully run it with the SP Execute SQL. Okay, and now on the guys' questions that you asked before the presentation, sprocs versus scalar functions. Scalar functions can't run non-deterministic functions like getDate. They are treated as a black box in the execution plan. When a compiler is looking at a query that has scalar functions inside of it, it's not going to optimize whatever's inside of that function with the outer calling query. You cannot do inserts, updates, or deletes inside of scalar functions. They cannot call CLRs, and they can only return a single result. Inline table value functions or single statement table value functions, they cannot do inserts, updates, or deletes because it is just a single query. You cannot run CLRs. It's the query only. There's no scripting logic. You can't do any sort of calculations inside of it besides what you do built into a query. It's only going to return one result set, but they're good for including in queries because the SQL server can read this, or the optimizer can read this, and it will actually just kind of pull that statement out and copy and paste it into the calling query. So those are good. So if you were going to have a single statement inside of a stored procedure and no logic around it, it would be better to have it in a inline or single table value function. On to multi-statement table value functions, these cannot insert, update, or delete like the inline ones. They cannot run CLRs like the inline ones, and their query plan is not cached, so it is a black box. I'm sure there's a place to use them, but the more I learn about them, the more I don't think they should ever be used. So I don't see any the goal of a multi-statement table value function would be, run a query or do some logic and return a result set. If you have to have that inside of a query somehow, you might as well maybe just have it in a sproc, call that sproc and fill a temp table or something that the query can be joined to or optimized somehow. Or maybe have it, if you have logic, then you couldn't have it in a CTE, but there's probably probably a better way to do it if you have to have a multi-statement table value function.
When you were doing the demos, wasn't it putting those in the temp DB anyhow?
I don't recall.
They were.
They were.
We're going to do the demos in a second. So is there anything, is there anything sprocs can't do then?
They're not. Well, you can't join to a stored procedure.
Okay.
So they have their place.
They do it all though.
Yeah, internally it'll run all the statements inside of the stored procedure, but you can't have a query and you want a result set, so you can't join to a stored procedure.
You select from the stored procedure?
No, you cannot. You can insert into a, say, temp table the result set from the stored procedure. Demos. All right, we've got our query training database, just inventory and category again, camping store. Okay, first, stored procedures, let's go over the basics. Create stored procedure. Zoom in here a little bit. This is the syntax: create procedure, schema, and the name, and then an as, and then clean code practices have a begin and end on it. I've created already. And then to execute them, you just, like in the slides, the sample is just exec. This query or this stored procedure has no parameters on it, so we can just highlight it and run it. And we return just the top one, inventory ID on the table. To change stored procedures, you just have a, say, alter. Use the create to alter, and you can run it. And it changes it. It retains any permissions around the stored procedure, like what database roles or database users can access it or run it or drop it or create more. And then there's, to drop it, you just say drop procedure. And then now it does not exist anymore. We can see that by saying alter. It says, oh, invalid object name, because it doesn't exist anymore. So we'll create it again.
You don't even have to execute anymore, right? You could just run the name.
You can also
since 2005
highlight it. And I'm not using in the menu here, I'm not hitting the run button. I use Alt X to run stored procedures. You can also use, or to execute, you can also use F5 to run things. 2-second improvement there. Yeah. Okay.
That's F5, but
that's too far. Yeah, it's too far. Okay. All right, inputs using single values. Previous stored procedure had 0 inputs. This stored procedure returned item quantity for inventory ID has 1 input, and it's an integer value. You have to declare the data type when you're declaring your input parameters and output parameters up here. And then this is just a single statement inside of it. Select the quantity on hand from inventory where inventory ID is equal to the inventory ID variable, which is the input parameter. So we'll go ahead and create that. And then just kind of show inventory IDs in the table. All the inventory IDs, and we'll just use that second one. So we declare the variable inventory ID to pass into our store procedure, and we're going to execute the store procedure with that hard-coded value and with that input variable. And I'll run both of those, and they return the same value. So you can see that it works. Store procedures work by either passing in hard-coded values or variables. So if you really had to, you could have a loop or a cursor that would execute a store procedure, with varying input parameters on each iteration. Now we will show using data set or tables as input variables. So this is how you declare a custom data type in SQL Server. So, create type, the name of the type, as, in this case, table. And when you, we'll run that, create it. And these stick around as objects in the database until they are dropped. So we will see them in source control. You could kind of use them as models, I guess, for objects. They don't hold data. They're just data types, so you could declare it, and then you'd have to fill it every single time, but at least you have a standard model of a standard structure.
Sure.
Yep. So we created it. So now we're going to create a store procedure that takes this new data type. And when you are passing in these new custom table data types, you have to mark them as read only. And this store procedure, we're going to select, just go with me on this one, we're going to select star from that table variable input 3 times. All right, so now we're going to call it. So you declare the temp table custom table type as our new table type. IntelliSense isn't picking it up, but you could be able to highlight it or mouse over it, and it would list this definition here. Going to insert into our table variable. I guess table variable. There are table variables in SQL Server, but we're going to insert into our custom table variable data type. And we're just going to select the category ID and category title from the categories. And what it will do is when we pass it into our test store procedure, we're going to get 3 result sets out of it. You can see 3 result sets there. And then let's just go see the no count. So no count was on, and we only see 4 rows affected, even though you have 3 data sets of 4. 1, 2, and 3 for each select statement. So let's turn no count off. Use up the alter. Run that, and now we'll execute our store procedure again with no count off. We get the result sets again, but now we get multiple hey, here's a result set, hey, here's a result set, hey, here's a result set. And if your application isn't built to handle that, it will kind of stop processing at the very first result set it gets back, or after that one. So you might, in your store procedure, you might have at the bottom returning the results that you want, but then you're seeing like really weird results. You're like, what's going on? What's going on? Well, it might be that, say you have set no count off, and your application is seeing that kind of first X rows affected or N rows affected.
Interesting.
Important to have no.
Yeah, that would be a tricky one to find if you haven't seen it before.
Yeah, that's why it's important to, just kind of as your coding standards to set no count on by default, or have it in your code review standards. All right. So we'll turn that off and or set that back on. Now we're going to run that again with the exec, and then we're also going to run the SP_execute SQL. Cannot find it. I'll just continue on. It's there. So the syntax for SP_execute SQL. The first parameter is your query, what you want to pass in. Needs to be parameterized. And then your parameter definition, which is a comma-separated string of your parameters. So this one is one parameter. If it had two parameters, it would be, param2 int, param3, etc., etc. And then after that, there's an n number of parameters that you can attach. And this is the actual kind of data of those parameters. So in this case, I'm passing in, I'm calling a stored procedure as one parameter. And it's the temp table. Here I define the temp table. And here's the actual value of the temp table. This could be, the names don't have to match up. This could be, temp table values. And since it is the first one in the list, it will param2. It won't be confused with this parameter definition over here. So we'll run that.
I think values up the last parameter.
Oh yeah. Never supposed to type during demos, but week was pretty busy. Get it all done. So we can see here, we get the first 3 results sets, and then we get another 3 result sets from the SP_execute SQL. So it's a handy way and a SQL injection proof way to build up a SQL query. You don't use the question marks. You just use the actual parameter definitions, and then you can call that SQL with the defined parameters. That way you can, if you use this method, you don't have to have a bunch of ands or ors. Hey, we might use this parameter in the SQL statement. We might not. If we don't use it, we don't really need to join to those tables. So instead of a left join, you just don't need to build them into the SQL query. And then you can have a kind of a fine-tuned SQL statement with just what you need. And then you can run that and get a good plan for that query right then and there. All right, so now we'll cover the outputs. Create store procedure. We have our item SKU input. So store procedure is return item ID for the item SKU. So pass in the item SKU and return inventory ID, which is an integer, as an output. So in the store procedure, it's just a single query this time. Here's the input parameter, the item SKU, and this is the output parameter. We don't need to select inventory ID at the very end to kind of have it be the last result set. When the store procedure runs, it's just going to return the output, the variables marked as the output variable. So we'll create that. Since we're using an output variable, we need to declare it outside of the store procedure, or outside of where it's called. Have it here in the parameter list for the store procedure, and we can select it afterwards because it now is filled. So we'll look up the inventory ID, or sorry, the quantity on hand. Didn't make it over. The quantity on hand, I should say, we can see up here, the quantity on hand for a given item SKU. And we can see that it is 5. Does that make sense? You have to declare it on the outside, and then you can get it back. The names don't have to match up, of course.
So do you have to guarantee only one row returns from it, or does it just grab the first one on a single value type one like this?
The question was, you
Like you have to put top one or something, just or whatever, or guarantee, or
well, if I don't have a top one in here, SQL will complain saying, hey, more than one result set is returned.
yeah.
You know, you can't put more than one into a single variable. You cannot. Oh, what's the next question? Next sample is, well, what about custom variables, custom table variable data types as inputs and outputs? Because we demoed that you can have it as an input. Well, what about inputs and outputs? So we'll create a new data type category, category IDs, data table type, category ID, categories table type, category IDs data type. So let's create them. And we'll try to create the store procedure. Return item IDs for category ID, where we'll pass in this new data type for tables. It has to be read only.
And that's a different name than your type, right?
Yeah, but it doesn't matter because it won't work anyway. So, yeah. See, it's complaining already. You know, it works for the input because it's a read only. You know, we're passing in a result set into the store procedure, and kind of try the inverse of that is of, you know, having it read only output. And you go to create it, and it'll say bad syntax either way.
Can you take out the read only?
It says table value parameter and very. Yeah. Yeah. So with the custom data type of tables, you can pass them in store procedures, but you cannot modify them in any way, and you can't have them as output variables. So if you're going to have an output variable, what you can just do is we'll create a store procedure passing that data type in. And we will just select inventory ID, which is we were trying to select into our custom table variable up here, which didn't work. So if you wanted to do that, you declare a table variable or temp table on the outside of your store procedure. Here we are declaring that data type again. Categories table, we'll insert into that categories table with values of 1 and 2. So give me all of the item IDs for that have a category value of 1 or 2. We'll execute our stored procedure with our temp table. But what we're going to do, Cody, is insert into the temp table we declared before the results from the stored procedure. And then we will select out of our temp table, which we just filled. And we'll also, just to kind of verify the data, select from the inventory table where category ID is in 1 and 2. So we can see here the first result set is the select from our temp table. And that matches up with, a select from the actual inventory table where the category ID is in 1 and 2. So you can see that you can insert into a temp table with the output records or output result set from a stored procedure.
Question: is the this type object something new?
The question is this custom data type variable, custom data type, a new feature? I don't think it is. I think it's been around a while.
It's been released 2005.
Yeah.
Custom table type? Or custom, what is it?
User-defined data type.
A user-defined data
Yeah.
type.
You
So-
can't have columns that are user-defined data type.
No.
Nothing new. Anyway, that's cool though. I like that. That's
Yeah.
good for models.
Yeah, it's perfect for models because you declare this table as this variable as this custom table data type, and you say insert into it, and it just spits out everything that you need to insert into it. With like IntelliSense and SQL prompts. Right, and we kind of covered this earlier, ways to call stored procedures. We declare our temp table. We have the exec statement and the execute SQL. And they return the same results. So, any questions?
So these user types are persistent, right? They're like stored procedures and views and other user-defined functions and things that stay in the database. They're not like transient with the batch or something like
Yeah,
that.
the question was, are the custom or the user-defined data types persistent? Yes, they are. They do not get dropped when you're done running the stored procedure. Those do stick around in the database until they are dropped. So
So
you
unlike
can have,
a lot of this stuff you could do with CTEs, right? But those are transient kinds of
yes,
snapshots.
yeah, CTEs themselves are not only, they're not even dropped when they're out of scope. CTEs are just a code snippet that
They're just refactored in.
gets kind of copied and pasted by the optimizer into wherever they're called. So they don't ever touch the temp DB like table values or table variables do, or temp tables. Temp tables do. Those are written to disk. Table variables are not written to disk. But either way, they are existing in memory when they are filled. So that's why CTEs are kind of even better, are better than both of the temp tables or table variables, because those aren't even, they don't even touch memory or the disk at all. But that's, I guess that's separate than your question on the user-defined data types.
No, they're not just, making
And
sure
yeah,
they're like,
they exist.
they're like drop, alter,
Yep,
create types, right?
yeah, they exist for everybody. And since they exist, I assume you can even have permissions on them around maybe who can access them or not.
And then,
Maybe. I
yeah,
don't know. We'll have to experiment with that.
Back, you had a example with single value table functions and multis. Does it just know by the type of select that's in there if it's a multi-row or single, or is it the begin end that keys it off, or how does it know the difference?
It's the begin and end that keys it off. When you define or when you write an inline or single statement table value function, you just say, create the function as, and then your select statement. If you put a begin and end on there, then it treats it as a script.
Even with a single select?
Even with a single select.
Hmm.
So you could be robbing yourself of,
You think
tons of
begin ends are
performance.
just block delimiters, but they're actually big
flags.
optimizer deeds and deals.
Yeah,
in this
de-optimizers. Yeah.
Yeah.
So you have to be careful on how things are scripted.
I notice you don't use parentheses when calling sproc, but you do when calling a function. Is that correct?
Correct.
The parentheses.
Yeah. So the question was, you don't need, or you do not use parentheses when executing a stored procedure, like right here. And yes, that is true. And then you do need to use, say this return items for category ID is a function, and you would need to use parentheses around that.
If you're in a function, you can call a stored procedure, and there's something around.
I want to say no, you can't.
You can go the other way though.
Yes, you can definitely call functions from stored procedures, but you cannot call stored procedures from functions. So in my experience of what I've seen so far, it's for performance, it's best to use functions for a standard way. You pass in all your fields into the function, say like for formatting addresses or names. Pass all your fields in, do the formatting, and pass them back. Don't pass like a user ID into a function that goes and runs a query on that user ID to get fields, format a name, and return that. Especially when you're joined to that users table on the outside already, just take those fields and format them appropriately.
In stored procedures, they have lots of different logical paths.
Yeah.
That messes up things.
Yeah, it's best to keep stored procedures as simple as possible. Don't use go-to statements. I'm guilty of that. I'm raising my hand right now, but that was a long time ago.
So functions are basically simple computational or
Yes.
simple formatting maybe, but not really select style things. Really, you want select statements and stuff like that and procedures.
Yeah. So the question was, is it a bad idea to have queries inside of scalar functions? And yes, unless you have to. And there's always, I'm sure there's some business case somewhere that they're necessary, but
We have some.
reasons to not use them, there's a lot of reasons not to do it that way.
So a scalar function, does it have begin and too? Is it or something, or is it? Why couldn't it optimize those inline as well if they're just doing a select with a single result?
So the question was, why can't the optimizer look into a scalar function and optimize the output?
Same as a single one.
So the single statement table value function, or the inline one, there's a query inside of it, and on the outside of it, when you're calling it, you're joining to it, in a certain way. So it can just copy and paste it out into your outer query. With the scalar function, it's not going to know you're doing data manipulation inside of it. So it can't, it's going to be a different, it's not deterministic, it's going to be a different result for every parameter you're passing in. So it would have to actually go and do all those computations, whereas with the inline or single statement table value functions, it's not looking for a result out of that thing. It's just trying to make a plan of how to go and get the results.
It's always the same operation.
Yeah, it's always just the kind of same operation, same template of how to include. How can I incorporate this template with this outer template? Whereas with the function, it's I need to change whatever's getting passed in and return a single result.
It just seems like the scalars have two classes, right? One that's like a select of a single value, and others that are computational, non-deterministic. Like they have both kinds of scalars. You think they could optimize the deterministic types?
Well,
Because you could do the same thing in the sproc.
You
either
do, but then you have to do another
it'd have to
join
be,
or whatever.
yeah, it'd have to be ran ahead of time. If
Like I'm thinking of a specific case in my past, right, of course.
Yeah.
Where we had a lookup table and we'd pass in a string value and it would return the ID of that type. And we put that in a function and it just did a single select on a small table and returned it. It just changed human readable types into IDs.
Mm-hmm.
And put those in there where the ID is equal to product category or whatever.
Uh-huh.
And it made those queries probably run, big queries run 10% slower just because of that one thing versus a join.
It was running that select statement for every single row that it was encountering.
Probably.
So
that's what I'm saying. It could have made that a join like we did.
So say you have 10 rows in your outer table and your lookup table has 100 rows. For that first row, you're in your outer table, it's going to scan because it's only 100 rows. So it's just going to scan your lookup table, scan 100 rows for that first row. Second row in your outer table, it's going to scan that 100 rows again. Third row, it's going to scan that lookup table another 100 rows. So it's going to scan that lookup table 10 times, it's going to scan it 10 times. So that's 10 times 100. So 1,000 rows that's going to look through. Whereas if you join, it's just going to set up, it only has to scan it once and create those relationships.
That's what I'm saying, right? Is in that case, it was a straight select on the same values that were being matched right in the where.
Mm-hmm.
That you would have thought it could have optimized it like a single row.
Yeah, but it doesn't know when you have that scalar function. It's a non-deterministic thing. It's not like a.
And maybe it could have in that case.
It would have to know more how to analyze it.
Yeah,
to figure out
if it was.
when it could or something.
Yeah.
It's probably something they could do. It would be that much more work for them, right? More features.
Yeah, it's like, why not just code it as a join in that case?
You could. It's just that coding like 2 or 3 joins in addition, for each of your selects, adds a lot more joins where you just say where type equals this, right?
Mm-hmm. So yeah, maybe in the future they'll have
there's just a lot more
way to
typing, a lot
define
more errors and stuff. Join.
Create functions to be more modular per se. Yeah, it's not scripting it's scripting. It's not a compiled language, so it can't
It's
compile.
not even scripting, right? It's a declarative language, right?
Yeah. Okay. Any other questions? No. All right.
Hey, we missed the